So the final question deals with the number of people in the world that are hungry or malnourished. So about 13 people of the 100 people are hungry or malnourished. In Canada, the number would be only 4 out of 100. So let's look at how many people are hungry or malnourished in Canada alone. So in Canada, we only have 4 out of 100, right? So that's a certain number out of, now it's not the world population, right? It's the Canadian population. So 35 million. Okay? So now, if I want to get rid of this denominator, right, I'm dividing by 35. So remember the opposite of that, to get rid of the dividing by 35, we can multiply by 35 on both sides. Okay? So in this case, we end up with 35 times 4 divided by 100, 1.4. So that means 1.4 million people in Canada are what we would call malnourished. Okay? So that's pretty alarming. Let's compare that to how many people are hungry or malnourished in the world. Okay? So we're talking about the entire world, so we need our ratio for the entire world, which is 13 out of 100, right? And that would be a certain number out of our total population of the entire world, which is 46 million, right? So now we can again get rid of our denominator. Right? And we can end up with 46 times 13 divided by 100, which is 915, but it's 0.9, so we can round up to 916, right? So we have 916 malnourished people in the entire world, which is pretty crazy. Okay? So that's the entire world. That's Canadian. And we, of course, saw here that it's very disproportionate, right? 13 out of 100 in the world, only 4 out of 100 in Canada. Okay? So that's that. So now you can hopefully see how just taking a huge number and scaling it down to a small number can help us think about what those numbers actually mean, because it's very difficult to try to think about what the number 960 million means, or what the number 7,046 million means, or 7,046 million. All those numbers are a little bit out of our reach, but if we can scale numbers down, which math helps us do, we can actually think about reasonably sized numbers, and we can compare numbers like 4 to 13. We can see the 4 is a lot smaller than 13. We can actually see the 4 is about a third of 13, right? But with these huge numbers, it's very hard for us to compare numbers against numbers. So this is why we need ratios and proportions, so we can scale things down to a size that we can talk about. All right?